I want to talk to you a little bit about solving absolute value problems. There's a couple of variations on a theme and a couple of different things that I'm going to say in here that are perhaps a little different from things you've done in the past. First of all, this definition of absolute value is really important that you understand and be able to think through. What this is saying is that the absolute value is what's called a piecewise defined function. If what's in the absolute value, x, if it's bigger than 0, that's what that says, then the absolute value is just that number. But if the thing inside the absolute value is less than 0, then you have to take and read this as the opposite. You take the opposite of that number. For example, if I take the absolute value of 5, well, 5 is bigger than 0, so you just take the absolute values of signs away and just have 5. But what if I was taking the absolute value of negative 3? Well, the absolute value of a negative number, if that number is less than 0, then you take and read this as the opposite of. So the opposite of negative 3 is 3. Now let's do that with an equation. So what I want you to think about is this thing. That thing could be positive, that thing could be negative. If that thing is positive, then you just make the absolute value signs go away and you rewrite the equation without them. But if this is negative, then you have to take the opposite of that thing. And so the negative sign goes over here with the x minus 4. Now to solve, of course, the equation, you just add 4 to both sides on this one and get 14. Over here, first, of course, you need to distribute the negative and get negative x plus 4. And then you're going to subtract 4 from both sides. And then divide by negative 1, or multiply by negative 1, either way. And so both of these answers are true. Now, as it turns out, when you have the absolute value of a number is equal to something, you use the word or in the middle. Let's try another problem. Let's take the absolute value of x plus 3 is greater than, let's go with 11. Just making up a problem. Again, it's the stuff inside. So if that stuff is positive, then you just take that stuff. So let's assume that this is positive, so then it's just x plus 3 is greater than 11. But what if this is negative? Then I need to take the opposite of that stuff. And just oops, I put 0 for some reason. Let's change that to 11. So now I'm going to take this negative over here and distribute it and solve both of these equations. So this is just going to be x is greater than subtracting 3, and you're going to get 8. Distribute the negative, and then negative x is greater than, add 3 to both sides, in this case 14. And then when you divide by the negative 1, you get x is less than negative 14. Now if I were to graph this on a number line, here's 8, here's negative 14. Look at what this says. This one says less than negative 14. So I would have, let's go with red here, an open circle because it doesn't say or equal to, and I would shade this way. This says over here greater than 8, so again open circle and shade this way. Now as it turns out, in between these two things, in this particular case, you would also use the word or. So anytime you have an absolute value that's bigger than, greater than a number, you're going to use the word or. By the way, if back up here at the beginning this said or equal to, this would have an or equal to down here, then these dots would get filled in, of course. So let's try one more. Absolute value of 2x minus 5 is less than or equal to, and let's say 7. So I'm going to let this be positive and I'm going to let this be negative. So I'm going to take 2x minus 5 is less than or equal to 7. And I'm going to take the opposite of 2x minus 5 is less than or equal to 7. Now, a minute ago, back here, this was a greater than symbol. Now I'm dealing with a less than symbol on this problem. And as it turns out, the word that goes in the middle on both of these is the word and. Both of these are going to be true. This one and this one. So let's solve them both. Add 5 to both sides, you get 2x less than or equal to 12. X is less than or equal to 6. Distribute, negative 2x plus 5 less than or equal to 7. Negative 2x less than or equal to 2. And then x is, now remember when you divide by negative, greater than or equal to negative 1 with the word and in the middle. Again, on a number line, less than 6, greater than or equal to 1, negative 1. And as it turns out, then the answer is the stuff in between. And it would be closed dots on each of these. So I hope that helps you understand a little bit about absolute value and how it works. It's about the stuff inside the absolute value that it could be positive and if it could be negative. And if it's negative, you have to take the opposite of it.